Hello friends. In this video, I am going to demonstrate the Petersons solution with the help of C++ programming language. In my previous sessions, I have discussed how the Petersons solution is useful to achieve the mutual exclusion, progress and bounded waiting requirements of synchronization mechanism. In this demonstration, I am going to take two processes which will modify a same data item, and we will first observe how the two programs, if they run concurrently, end up in the problem of race condition. And to solve the problem of race condition means to achieve the mutual exclusion, we will introduce the Petersons solution and observe that the final value is as expected even both the processes execute concurrently. So let me take this problem statement where I am going to first define the initial bank account balance as 100, and I am going to write two programs, program 1 and program 2. Let's say the first program will deposit 2000 rupees to the bank account, and other program is going to withdraw 2000 rupees from the same bank account. Now if you think logically, if I deposit 2000 and if I withdraw 2000, then after the execution of both the programs concurrently, no matter concurrently or sequentially, at the end of execution of both the programs, the final value of the bank balance must be 100. So let me jump to my Visual Studio and start writing the program 1 and program 2. So here is my Visual Studio. You can download the Visual Studio from Microsoft website. So I'm going to create the new project for writing the program 1. Let me give some, first let's find the C++ and I'm going to create the console application. Let us give some name to the project. Let's say money deposit program, and I'm going to store this program. So I have created two different folders. One folder is money deposit folder, where I'm going to store the program 1. So at this location I'm going to store my program. So let me create this project. Here is my environment. Let me delete these comments from here. Alright, and let me put my own comment. Program to deposit 2000 to bank account. Alright. So as I said, I'm going to write two programs, and both the programs are going to share one variable called as bank balance. So to declare a shared variable, I am going to use the Boost libraries. You can download the Boost libraries for C++ and use it for free. The Boost libraries makes easy to write the program for multiple platforms, that is Windows or Linux. So you can download these Boost libraries from this boost.org and start using those libraries. So I have already downloaded those libraries, and I am going to just use those libraries. So let me say #include Boost. There is a namespace called as interprocess. Under you will find one library called as shared memory object. The another header that I am going to use from the Boost library, interprocess and mapped regions. If you want to learn more about how to declare a shared memory, you can follow the documentation of Boost libraries. So now I'm going to define the initial bank balance as let's say 100. Alright. And with the help of these libraries, what I'm going to do, I'm going to define shared memory. So with the help of this shared memory object, I'm going to define SHM1. SHM1 is my variable name of shared memory. To use this, I have to first say using namespace boost interprocess. Okay. Further, I am also going to use this detail namespace as well. So let me include these namespaces, and now the error is not there. So one variable I have declared SHM1, in which I am going to store the initial bank balance. Alright. So to declare the shared memory and put some value in that shared memory, I'm going to write one function, let's say integer star. The return type would be pointer to that memory location, and I would say get shared variable bank balance. So here we are going to allocate the memory for the bank balance in the shared memory 1 and initialize the value to 100. So first let's remove if it already exists. So you can use shared memory object, you can say remove, and you have to provide the name of the variable, let's say the bank balance. Alright, so let's assume that if the shared memory of the name bank balance already exists, let's first clear that. And now I am going to allocate the memory for bank balance in the shared memory 1 like this. So I say shared memory object, and to that you have to pass the 3 parameters. The first parameter would be the mode. So I want to create the variable. The name of the variable would be bank balance, and the read write mode you have to provide. So I will say read or write. After that, let's set the size of the memory. To set the size of the memory, you have to say the shared memory dot truncate. Oops. So this should be SHM1 dot truncate, and how many bytes you want to allocate, you have to provide the number of bytes. Now I want to store just an integer, that's why I will say size of an integer. Now once you declare this shared memory and set its size, to access this shared memory in this program or in this process, we have to first map it and then set its initial value. Alright, so the mapping is done with the help of the region. So I'm going to define one region. So along with the shared memory, you also need to define mapped region. I say region 1. And let me use this region 1. Alright, so let me use this region 1 to map it to this particular process or program. Now you just have to say region 1 dot get address. So this process will get the address with the help of which it can access that shared variable. So where to store that address returned by this call? So let me define an integer pointer p, but this get address returns us the void pointer, and that's why I have to cast it to the integer pointer. Now this integer star p, once we catch the address from the region 1, you have to just assume this integer pointer as like any other local integer pointer. Alright, so I am now, with the help of this pointer, I am going to set the initial value of bank balance as 100. Okay, and finally I am going to return the address to the main function. So this completes my function, this function get shared variable bank balance, which is responsible for allocating the shared memory and then initializing the shared memory and then mapping it to this address space of the process and then use it with the help of a pointer. So as this function I have written below the main function, I have to give the prototype before the main function, and now in this main function I am going to write the program to deposit the money. So let me say program to deposit money to account, and I'm going to take one local pointer integer star bank balance is equal to, I have already defined the function, so I'll say get shared variable bank balance, alright, which will return me the address to the bank balance shared variable, and then I can use it. Now let's deposit 2000 to this account. So I'm going to write a for loop. Let me define an integer I initialized to 0. I can say for loop I less than 2000 and I plus plus. So let me deposit the 2000 rupees to this bank balance one by one. So what I'm going to do, first I'm going to read the current bank balance. So current balance is equal to value at that address, and value at that address I am going to use that pointer. So once I read it in a local variable, now I will increment by 1 plus 1, alright, and then I'm going to again store back at the shared memory. Alright, so that way this for loop will deposit 2000 rupees to this bank balance one by one. So it is adding one by one. Okay, and just to nicely show it in the output console, I'm going to just write printf statement, and this printf statement will indicate that 1 rupees has been added to the bank. So I'm just going to print the dot. One dot will indicate that 1 rupees has been added. So this for loop will print 2000 dots, indicating that 2000 rupees has been deposited to the bank balance. Alright, so that is my program, and at the end of for loop, what I will do, at the end of for loop I am going to again print that money depositing has been completed and bank balance is, let's print the value of bank balance directly from the shared memory. Alright, so let me execute this program, see if there are some errors or not. Yes, I got the output. So program has been started, and at the end of this execution, the money has been deposited, and initially I allocated 100 rupees, and at the end of this program, the bank account balance is 2100. So let me close this program. Let me add one line that initial bank balance is %d . And let's pass the value of the bank balance. So I need to shift this statement below this pointer. So just before the for loop, I am going to print the initial value of bank balance. Now you see the output I got pretty fast. Now to just observe the output carefully, what I'll do, I'm going to introduce one statement here. Just say sleep. So after adding some 1 rupees to the bank account, I'm going to make this program wait for 2 milliseconds so that we can observe the output. We will get time to observe the output. Okay. So let me run it one more time and see how output looks like. Yeah. So here is the program running, and at the end of execution, I got the final value as 2100. Initial bank balance I have printed as 100. So that is my program of the money depositing. So now what I'm going to do, I'm going to write another program, and same logic I'm going to put there, but in the other program I'm going to withdraw the money. Alright, so let me create another project. So let me create another project, keep the early project as it is, and you can just start the Visual Studio one more time. So create the new project. Let's select the C++ console application. Give the name as money withdraw program, and I'm going to store this in some other folder. So let me create one folder called as money withdrawal program, and I will give this path to store my project. Alright. So it is the second program created, Let me clear out these comments and let's give the comment as this program will withdraw 2000 rupees from bank account, the same bank account. Okay, so what I'm going to do, I'm going to copy the entire program from here, money deposit program. Alright, let me walk you through the from beginning. So let me clear out this comment. It is a money withdrawal program, and this program will not initialize. So let's assume that the depositor will initialize it. So these all are required here, and let me first modify this get shared variable bank balance. So I don't want to remove it first. Let's clear that statement, and here I'm going to say open only, because I assume that that is already created by the depositor, and read write one more time. I don't have to set the size, it is already set by the depositor program. I'm just going to read and modify the value of bank balance in this program. So in region 1, and I don't want to initialize the value, I'm clearing that statement here. That's it. So just get the shared memory, map it to your program, and get the address of that variable and start using it. Now let me jump to the main program, main function. So in the main function, I will say program started to withdraw money from account. And I don't need to print the initial bank account balance. It will be printed by the depositor. In this for loop, I'm going to, instead of +1, I'm going to say -1. And that's how one by one I'm going to deduct or withdraw the money from this, the same bank account. Let me save this program and build this program. Okay, the build has been successful. Let me again go further and modify this printf statement. Instead of saying depositing, I will say money withdraw has been completed, and the bank balance is, I'll say the final bank balance is the value of the bank balance. Let me again build it and execute. So here is the program started, and I'm getting the output. All right. So let me just close this. So my two programs are ready. The first one is depositor and the other one is the withdrawal. So I'm going to modify the comment here, withdraw one by one. And also let me modify this comment. Let's withdraw 2000 from this account. Let me build it. Yeah, the build has been successful, and let me just go back to the depositor program and also rebuild it. So I have both the programs ready. One is going to deposit and other is going to withdraw. Now what I'm going to do, I'm going to start these two programs concurrently. So let me go to that folder where I have created the binaries. So here is my money withdrawal program and here is my money depositor program. Now I'm going to start this program and observe the output. So let me start the depositor program. Here is it started. Meanwhile, let me start so both the programs are running now. You see? Oops. So I need to add getChar at the end so that my program will halt. So let me just go back and add the getChar at the end of program so that I will get a chance to observe my output. Okay, so let's rebuild it one more time. So the build has been successful for withdraw program, and the build has been successful for the depositor program also. Let me again go back to my folder. Now here are the new binaries ready. So both the programs are rebuilt and both the binaries are updated. Now let me run both the binaries concurrently. Let me first start the money deposit program and quickly let me start the money withdrawal program as well. Now you can see both the programs are running, and you see the money depositor, let me dock it properly. Okay, so when I started both the programs concurrently, the initial bank balance was 100, and meanwhile it is depositing, I also started the money withdrawal program. Okay, and if you observe, after the depositing, the bank balance became 1084. By that time, this withdrawal program has not completed, and after the completion of withdrawal program, the final bank balance is 102. Now this 102 value is wrong, isn't it? What was the expected value? Expected value was 2000 only, correct? Why? Because 2000 has been deposited and 2000 has been withdrawn. So that's why my initial bank balance account and the final bank balance account should have been same. Okay, now how to fix this problem? Let us now introduce the Petersons solution in our code. So let me first introduce the Petersons solution in the depositor program. So let me go back to the depositor program, and what I'm going to do, I am going to declare the variables for Petersons solution. So I am going to require 3 shared variables for the Petersons solution. Let me say SHM2, SHM3 and shared memory 4. Remember that for implementing the Petersons solution, we require the turn variable, which is shared between both the processes. The flag variables, there are 2 flag variables, flag 0 and flag 1. And that's how for these 3 variables which are required by the Petersons solution, I am going to define 3 shared memories. Now with these 3 shared memories, let me initialize the shared memory and initialize their values as well. Similar way we did for this bank balance. So let me copy this, and I'm going to write for the next methods which will allocate the shared memory for turn, flag 0 and flag 1. So shared memory variable turn and the shared memory variable flag 0, and again flag 1. So let me implement these methods now. Okay, the similar way I am going to just copy this entire function. So the first variable would be the turn variable. So first, if it exists, let's going to remove it, turn variable, and then declare the shared memory for this turn variable. Set the size to, it is also an integer, set the size of integer, but instead of that I'm going to use the shared memory 2 Here also the shared memory 2, and I'm going to map it to region 2. And I want to initialize the value of turn, let's say 0. This is one function. Now similarly I'm going to copy this again and declare the next variable which is required for Peterson's solution, which is flag variable. There are two flags required, flag 0, alright, and let me say flag 0. This time I am going to use the third shared memory, which is SHM3. Oops, let me change it, flag 0. Shared memory 3, and let's map it to the region 3. The initial value of the flag will be set to 0. Remember that in Peterson's solution we set both the flags initially to 0. And the third function for declaring the shared variable, that is flag 1, let me change it to flag 1, and this time I am going to use the shared memory 4, the region 4, and the initial value of flag 1 is also set to 0. So my three variables are ready now for implementing the Peterson solution. Alright, so let me go in the main function. Okay, now we know that the bank balance is a shared variable. So this is my critical section I want to mark, and before critical section I am going to put the Peterson's entry section logic, entry section of Peterson's solution, and the exit section of Peterson's solution. Okay, so what is the entry section? In entry section, you remember that we first set the flag 0 to 1, okay, and in other process we set the flag 1 to 1. So let me get the pointer of all the flags first, all the variables first. So let me copy it. Okay, so here let me say this is my variable turn, this is my variable flag 0, and the third variable which is flag 1. Let us get the pointer from the respective functions. So variable turn, flag 0, and flag 1. Alright, so once I get the pointers to these variables, I can use them. So in the entry section, first I am going to set the flag 0 is equal to 1, saying that this process is interested to enter into critical section. The next statement in the Peterson solution was value of turn we have to set. So I am setting the value of turn is equal to 0. Let's assume that this is process 0 and assume that the other process withdrawal will be process 1. Alright, and after that I have to write the busy waiting statement, that is spin lock statement. And what is the condition in the spin lock? If other process flag is 1 and turns value is equal to 0, then I'm going to loop here. You see there is a semicolon here. Alright, why it is an error? Oh, so there is a spelling mistake. It should be flag 1. Alright, So this completes my entry section of Peterson's solution. Let's write the code in exit section. And you know that in exit section, just we have to say my critical section work is done and I'm setting my flag to 0. And that completes the program of the Peterson's solution here. Alright, let me walk through this program. The entry section, we have written the flag 0 is equal to 1, turn is equal to 0 and the busy waiting condition. And in the exit section, after the critical section, there is exit section in which I have to say my job is done in the critical section and set the flag 0 is equal to 0. Now let us modify the money withdraw program. We are going to introduce the entry section. Let me copy it and go to the money withdrawal program and paste it here. So instead of flag 0, here I will say flag 1 set to 1. Instead of turn setting to 0, I am going to set it to 1. Here I am going to check if other flag, that is flag 0, is 1 or not, and the turns value is 1 or not. So exactly opposite logic in the entry section here. And in the exit section, what we wrote in the deposit program, that is flag 0 is equal to 0. But here in money withdraw program, I am going to say flag 1 is equal to 0. Now we have to define this flag and turn variables in the withdrawal program also. So the way I have defined it in the depositor program, let me copy those functions. Alright, these are the pointers and let me copy those functions now. So these are the 3 functions we wrote in deposit program. We will require them in the withdraw program also to access the shared memory. Alright, and we need to also copy those functions where we have actually accessed the shared variables. So here is my function for turn variable, function for flag 0 and function for flag 1. So all these 3 functions. I have copied and just paste here. But here let's just read the variables. I don't want to remove it and neither I want to create it. I just have to say open the existing variable. Don't set its size, it's already set by the depositor. And don't modify the value, we are just going to read the existing value. Similarly, the flag 0 also, in the flag 0, I don't have to remove it. It's a open only. Don't set the size. And don't initialize the value. Let me change the turn variable also. So in the turn variable, it is again already declared or and initialized by the depositor program. So here I am going to say only open. Don't truncate it here. Truncate is just a function which allocates the number of bytes in the shared memory. I don't want to do that because it is already done there. And don't initialize the value here. Okay. Just we are going to read. Alright, and I have to declare the shared memory variable and region more also. So let me copy those variable also from depositor program. Let me save both the programs, and let's try to run these programs now. So let me just walk you through one more time. Depositor program we have already discussed. So these are the three Petersons solution. These variables are required for implementing Petersons solution. And I have used these three variables to protect the critical section by writing the entry section and exit section. And similarly, in the withdrawal program, let me scroll up. Yeah, in the withdrawal program, we are going to remove or withdraw the ₹1 one by one from this bank balance account. And here the logic is exactly opposite. And that completes our implementation. Let me save it and build the programs. It is built, and let me build the depositor program as well. Alright, so both the programs have been compiled and my binaries are ready. So let me again go back to my binaries. So these are the two binaries which are ready, and now I have Peterson's solution in place to protect the critical section. Now let me start this program again concurrently. Let me start it, and quickly I'm going to start the withdraw program also. So both the programs are running. Yes, and this time let me dock it properly. Let's observe the output. This time program started depositing money 2000, initial bank balance 100. And at the end of this program, it says bank balance is 939. Meanwhile, this program has already started money withdrawal. And at the end of money withdrawal, you can see that the final bank account balance is 100 only. Alright. So we are getting the expected value as per our design of this problem statement. Alright, so initial bank balance 100, deposit 2000 and withdraw 2000 concurrently. And even if these programs are running concurrently, we are guaranteed to get the final value as expected. Let me again close the program. Let's try one more time. If I again start the program, they are running concurrently. And see, again I get the final value as 100. So no matter how many times you run these two programs, means two processes concurrently, this final value 100 is going to be guaranteed. So I conclude this video here. Thank you for watching this video. If you have any comments or question, feel free to put in the comment box.